right, so we've been going to look at bivariate data, so where we are looking at two variables, and we'll be investigating, when they say the association, that just means investigating how they react with each other. Now, normally we'll have the explanatory, so we'll be looking at how the response is changing when we change the explanatory variable around. So this one we're looking at today is when we have two categorical data pieces. So say we've got an example that we're going to go through with it. So when we have two categorical variables, we'll use a two-way frequency table. So you might just write their two categorical variables just to make sure that you realise that. That's the type of graph we would use for that. So suppose we did a survey and we looked at attitude for gun control. So you had to pick whether you were for, they had to pick whether they were for or against gun control. And then they recorded whether you lived in the city or you lived in the country. Okay, so where they're saying the residence is the explanatory variable. So that's either the city or the country. That's the EV. And the attitude to gun control is the RV, the response, because we're going to see whether they respond differently. So what we're going to do is we've got this two-way frequency table, and you can see that you've got the attitude on one side and the type of residence on the other. So when you have these two-way frequency tables, the RV is going to be here and the EV will be on the way in the columns there. So what you have to do is when you're completing, so you've collected the data, and we will often summarize it up. So you can see they're doing the totals where they're going 32 plus 30, and we do totals, and we've also done totals that way as well. All right, so we might needed that. So the shaded region in the table are called cells, and it is the number in these cells that we look at when we're investigating the two relationships between two variables. But the thing is, looking at the numbers, sometimes it's not really going to tell us too much about the association when we just look at the raw data, which is there, the numbers, because we might not have had the same amount of people that we were surveying. So say there was more, if you look at the city people, we had 42, country we had 58. So when you sort of don't have the even amount to look at, we would change it to a percentage. So we're going to look at changing this to a percentage frequency table. So moving on to the next bit. So here's where we're going to change to a frequency table. And as you can see, so if you want to look at how they found this, so if you look at, say, this, I'll do this one here. So what they do is it's out of the city people, they went for how many were for. So if you look, there were 34 guns in city, and out of the total of, I think, was it 42? So total for city. And then you times it by 100, okay? So that's how they're getting those percentages. So you need to know how to do that as well. So once we've converted it to a percentage, then what we're going to see is look if there's an association. So just, we might just want to write a little note over here. If there is a difference, there's an association. So if there is a difference, there is an association. Okay, so if you want to add, the other thing you want to do, and you want to compare one category. So there's no, you want to compare one category. And what I mean by that is, say for example, I'm going to look at the 4. So I'm looking across at the 4 there. So because 55% of the country people were for gun control, and in the city, 71.4%. Now, there's a big enough difference there between city and country. So therefore, you would be saying there is an association. So we'll say we think there's an association between attitude and gun control and residents, as we saw 55% of the country people were for, which was less than the 71.4% that the city were for. Okay, so can you see I'm going to compare the same category, going to use stats, and also I'm going to comment there's a difference. So I said one was more, one was less, whichever way you're talking. It doesn't, as long as you're saying there's a difference there. So that's what they'll be looking for. So here down here, they've explained that out. So it says the fact that the percentage of country people for gun control differs from the percentage for city people for gun control indicates that a person's attitude. So we're just saying it indicates, we're not saying it causes it. It's just we're looking at the study and we're saying, yep, this is what the study shows, that when you change venue of living, you can see a change in attitude for gun control. Okay, so these things down here, the report, is what you're going to be asked to do a lot. So you've got an example here of one. You just need to make sure you sort of follow this, but with whatever scenarios or whatever stats you've got and that you've been given. So here's what I would have written if I was trying to say whether there was an association. It says in the sample of 100 people, a higher percentage of city people. So really, you don't have to do in the sample and all that when you're writing them out on the exams. You just probably would start off with there was a higher percentage of city people were for gun control than country, and then they've used so they've stated which there was a difference by saying one was higher. Then they've stated the stats, which is the 71.4 to 55, and then they're just saying you've probably been asked, is there an association? So then they're going, this indicates that there's an association between gun control and that, okay? So let's do this example. So the following data were obtained when a sample of 10 Year 9 students were asked if they intended to go to university. The gender of the student was also recorded. Okay, so we want to set up a frequency table, two-way frequency table. So you can see the explanatory variable would be gender. Gender's not going to change all of a sudden because you're going to university or whatever. Okay, so then this one's the response variable. Okay, and then you would just count through. So if I count through, I just went through and crossed them off. So say male, yes to university, we had 1, I think we only had 2, okay? So I ended up with 2, then 4 female, and 2 like that. So we should total these up. So if you look, we had 4 men in total, and we had 6 women in total, and then you can go out the total that way as well. There was 6 people going to want yes to university and 4 no, and you can see we should get a total of 10 here, and we do, because there was 10 people, 10 were surveyed. Okay, now what we would do is we would want to, because we only had 4 males and 6 females, we'd want to change them to percentages. So the way you would do, and I'm just going to do it in here next to it, you do the percentages via the columns. So what I'm saying, there's 2 out of 4 men times 100, so you get, that would be 50%. Okay, that's how I'm getting the 50. So this one would also be 50%. So this one is 67%, and this one's 33%. If you just want to show how I got that one, So that was 4 out of the 6 times 100 equals 67. So you've just got have that there in case when you get one, you've got to do one on your SAP or in the exam, you might be asked to fill in one missing box. You'll understand what you're doing there. So remember, the percentages are occurring out of the column totals. All right, so having a look at that, we've got, sorry, it's a little bit messy now, but we've got, I'll just look at one category. If I looked at this no for university, 50% of males say no to going to university, and 33% of females say no to going to university. So I was going to say yes, there's an association there, yeah, because there's a bit of a difference. So I'd say because there was more males saying no to going to university with 50% compared to females saying no to university, which is 33, we can say there's an association. Sometimes you could argue, either way. So I picked a category. So this first one in the table 2, so I'm doing this one here. In table 2, the data, the study of association between the variables frequency of nightmares, which were, and you said high or low, and whether they snore, yes or no. So this, you can see this would be EV, and this will be the frequency, this is RV. Okay, because you're measuring, you're looking at the nightmares and stuff. Okay, so it says the percentage. Now with these questions in the exam, you're going to get this. Be really careful. I want you to start highlighting what they say. So when they say percentage, you should highlight that, because sometimes they say how many, sometimes they say percentage, and if you're rushing, you're not going to pick it up. This one, obviously multi-choice, they're all in percentage, but this is just a practice for all types of questions. So the percentage of participants in the study who did not snore is closest to. So if you go and you look at that, how many, so no snore over the total. So no snore equals 91 out of how many people were there looking at that table? How many people in the whole study? 161, yeah? Here's the total people. And then you times that by 100 and you end up with 56.5%, which is how we get the answer E. Okay, so then we're still looking at the same table. Of those people in the study who did snore, so be careful. Now they're only talking of the snoring people, the percentage that had a high frequency. So the total in snoring people was 70. And if we look at the high frequency nightmares was 12. So when we're calculating this, we're going to say 12 out of the 70 times 100, because they only was talking about the snoring. So you've got to be careful with reading the question. And that ended up being 17.1%, which is how we get B. All right, so the following two-way frequency table was formed from the data generated when the entire population of 62 types of mammals were similarly categorized. Okay, so we've got that. And it says how many, so this is where I'm saying you often got to highlight this, because it's not a percentage, it's just asking how many. So that means it's an actual number. So how many of these 62 mammals had both high likelihood of attack, so your high likelihood of attack and high exposure. So if we look here, we can see we got 15, yeah, out of everyone. So hopefully that was an easy one. Now, of the mammals with medium likelihood of attack, so they're only talking about the medium likelihood of attack. So that means we're only talking about these guys. So it says what percentage, so percentage is the question, had a low exposure. So of them, you want the low exposure. So what you actually have is there's a total of 4. So you're actually looking at 2 out of 4, and then you would times it by 100. So you end up with 50%. Okay, does the association in the table above support the contention that likelihood of attack is associated to exposure of attack during sleep? So sometimes it helps to write the EV and RV, and remember you're only going to choose one category. So I'm going to choose that top category. So I'm going to choose this low one across here to comment on it, all right? And that's what they're saying when they said, first of all, they say justify quoting appropriate percentages. So I'm going to have to change them to percentages. And they're saying you don't have to show all of the categories. So I've picked the low category. So what I'm going to do is I have to change this 31 to a percentage. Now, remember, you have to do it out of the totals of the columns. So if I go across here, the total of this column's 34, this one's 9, and this one's 19. So when I'm working out a percentage, this one would be 31 out of 34 times 100, okay? And this one would be 8 out of 9 times 100, and this one would be 2 out of 19 times 100. And then if I'm just going to write the percentages above it. So and I'm just going to round it. It's about 91% for that one, and 8 out of 9 ends up being 89% for that one, and then the high one ends up being 11%. So because it's changing, so as I go across the exposure of attack during sleep, so as it goes from low, medium, and high, it's decreasing in percentage, yeah? So that means there is an association because there's a change. So I'm going to write that down here. So the percentage of animals with low likelihood. So I've picked the low. You might have picked another one, but as long as you percentaged it out, the low likelihood of attack, so decreases, because I saw it went down, decreases with increased, because as the exposure goes up, with increased exposure to attack during sleep. And I've said there is, and I've said that the change, and then I'm going to write the percentages. So low exposure, I'm going to write 91%, and then I'm going to say medium exposure, 89%, and high exposure, 11%. So this you could say this indicates an association. So you probably should you could just write yes and then write the percentage or whatever. This indicates an association. Okay, so in order to investigate the possible association with beak size and sex, the same birds are grouped by both their beak size, small, medium, or large, and their sex, male and female, and the results are shown below. So remember, this one's the EV, male or female. That makes sense. You can't really change that, and the response variable is the beak size. So it says, does this information provide support support the contention that the beak size is associated with sex. Justify your answer by quoting appropriate percentages. And once again, they're saying you only have to use one category. So I'm going to go with the bottom one, and I'm going to use this category. So remember, we need to have percentages. So I'd have to change this to a percentage, so which would be 27 out of 54 times 100, and that ended up being probably roughly 50%. It is, isn't it? 50%. And then the last one, this one would be 3 out of the 42 times 100, and we get that to be 7%. Okay, so we've got our percentages. So we are going to say yes, it does. So does it? So yes, it does support, because there's a change in percentage. There's 50% of the males have a large beak, compared to 7% of the females have a large beak. Okay, so that's a good difference. So we're going to say yes, that does support the contention that beak size is associated with sex, with 50% of the males having a large beak size, which is higher. So make sure you've got a changing word there, so, or a difference. So saying it's higher is saying there's a difference, yeah? Men is higher than females with 7%, okay? Of the women who were first married in 1986, so you're only talking about these, what percentage were aged between 20 and 29? So they've already done the percentages there. So you just have to do this percentage plus that percentage, because there's actually, they incorporated two categories there. So you've actually got 42.1 plus the 23.4, which equaled 65.5%. Okay,